In the first video, you saw us solving by using the square root property, and the answers were complex zeros, meaning that they had imaginary solutions. Now we're going to practice solving by completing the square. Meaning after today's notes, we would have reviewed both methods that we've used so far in part B of our chapter 2 unit. Remember, with completing the square, we want to get it in the form x squared plus bx, meaning that a must be 1. When I look here, if I'm trying to find the 0, I need to rewrite it so that it's set equal to 0. So I have x squared minus 2x plus 5 equal to 0. So first thing I did was set equal to 0. And now I'm going to work on getting it in the form x squared plus bx. Okay, so step 2, x squared plus bx. All right, well, x squared is already having an a of 1, so I don't have to do anything there. I want the x squared minus 2x, but I don't want this negative 5 over here, so I need to subtract 5 on each side. That leaves me with x squared minus 2x equals a negative 5. I left a blank space here, and I'm going to leave one here as well, because remember, what we do to one side, we do to the other. The number that I have to add is b over 2 being squared. b was a negative 2, so I have negative 2 over 2 being squared, or a negative 1 squared, which is 1, meaning I am adding 1 to each side. So I have x squared minus 2x plus 1 equals a negative 5 plus 1. By adding a 1, I've made it so that this is now a perfect square binomial, and I can rewrite that as x plus b over 2 squared. So I have x plus, I'm going to have my b over 2, and in this case my b over 2 was a negative 1, so that's minus 1 being squared, equals negative 5 plus 1 gives me a negative 4. Now to solve, I'm going to have to use square root property, which is why we reviewed it in the previous video. So the term being squared, the x minus 1 being squared, is by itself. Okay, I cannot add the 1 to the other side because it's inside of the parentheses. It's being squared. So I need to take the square root of each side in order to undo that power of 2. Now remember, when you take the square root, you need to put a plus or minus. So I have x minus 1 equals plus or minus the square root of negative 4. And we've learned how to simplify this imaginary solution. Remember, using product property, I can split this up. I still have my x minus 1 on this side. X minus 1 equals plus or minus. I can split this up as 4 times negative 1. So the square root of 4 times the square root of negative 1. Well, the square root of 4, that's 2. Square root of negative 1 is I. Now, hopefully you noticed x is still not by itself, so I'm going to add 1 to each side, giving me x equals 1, because I want to put the real number first, plus or minus 2i. So the plus or minus belongs to the 2i. We can't just save plus or minus till the end and write it with our final answer. Okay? So the plus or minus belong to the 2i, and when you add the 1, you cannot combine the 2 and the 1, because this is a real number and this is an imaginary number. They're separate. That's why we have to write it in a special form. This is standard form of a complex number. So really, I have two solutions. the first one is 1 plus 2i, and the second one is 1 minus 2i. Okay? Part B. Once again, we're going to complete the square, so the first thing I want to do is rewrite it as x squared plus 10x plus 35 equals 0. Alright, now I want to get it in that form x squared plus bx. You can see a is already 1, so all I have to do is move this 35 over to the other side. That gives me x squared plus 10x, remember we're going to add some number, equals negative 35, and add some number, because what we do to one side, we do to the other. That number that we are adding is b over 2 being squared. B was a positive 10, so 10 over 2 squared, which is 5 squared, which is 25. Meaning I have x squared plus 10x plus 25 equals negative 35 plus 25. This is now capable of being written as a perfect square binomial. Remember, that's x plus b over 2 being squared. So x plus my b over 2 is a positive 5, so x plus 5 being squared equals negative 35 plus 25, that's a negative 10. To get x by itself, we're going to have to use the square root property. So the term that's being squared is already by itself. So I can take the square root. The square and the square root cancel each other out, leaving me with x plus 5 on this side. And because I took the square root, I need plus or minus the square root of negative 10. Let's clean that up a little bit. The square root of negative 10 is the square root of 10 times negative 1. Square root of 10 times square root of negative 1. The square root of 10, its factors are 1 and 10, 2 and 5. None of those are perfect squares other than 1, so it just remains the square root of 10. And the square root of negative 1, we should know by now, is I. That's our imaginary solution. So I really have x plus 5 equals plus or minus 10i. Now remember that plus or minus belongs to the 10i. And x is still not by itself, so I need to subtract 5 from each side. We want to write a final answer in standard form. So the real number has to come first. The imaginary number will come second. You cannot combine the 5 and the 10. Okay? The real number is the negative 5, so the negative 5 must come first. The imaginary number is the one with the I, so I'll put plus or minus, oops, I just realized I forgot my square root, plus or minus the square root of 10i. So I have two imaginary solutions here, negative 5 plus the square root of 10i, and negative 5 minus the square root of 10i. I'd like you to pause the video and attempt these two problems. All right, hopefully that went well for you. Here's my work. Feel free to pause it so you can check your answers. For the first one, you should end up with negative 2 plus or minus 3i. And the second one, you should end up with 4 plus or minus 2i. Oops, excuse me.